Let's do an example on this. Let's say we have a discrete distribution. Well, this is the same distribution from earlier. We have at 1 and at 4, we have 1 over 4 probability. And at 2, we have 1/2 probability. Remember, we computed the mean, the second moment, the variance, standard deviation, mean absolute deviation, etc. of this distribution. And now we are going to sort of repeat it with a characteristic function. Well, except for the mean absolute deviation. So first of all, let's find the characteristic function. Just apply the definition. Expected value of e to the power j omega x. So that is the sum from k equals 0 to infinity, e to the power j omega k, weighted by the PMF value at each k value, each outcome. So that is at 1, k equals 1, the probability is 1 over 4. And when you plug in k equals 1, you get e to the power j omega. And at 2, we have a probability of 1/2 here. And at 2, we would have this as e to the power j times omega times 2. That's what we have here. And finally, we have an outcome of 4, k equals 4. Okay, the probability is 1 over 4, it appears here, times this function here, e to the power j times omega times 4. Okay, this. So this is the characteristic function of this distribution. Okay, from this, how to obtain the expected value? Just take the derivative and plug in omega equals 0 and then divide by j. Okay, 1 over j here and the derivative at 0. Take the derivative of this function with respect to omega. Okay, this is what you get. And then just plug in omega equals 0. That means these exponential functions will all be e to the power 0, hence 1. And these j's cancel out with these. And if you arrange the terms, you get 9 over 4, 2.25 as expected, as earlier. Let's do the second moment. Okay, this time around, I'm going to take the second derivative and evaluate it at omega equals 0 and then divide by j squared. Well, j squared is exactly -1, but well, here the terms are going to cancel out again, so no need to actually put in -1. So, well, I have here, I should have equals 1 over j squared, and that is forgotten. And then here, well, this is inside here, we have the second derivative of the characteristic function and evaluated this at omega equals 0. So again, this term, this term, this term will be all ones, and the j squares will be canceled out with this term here. So arrange the terms, add them up, you get 25 over 4, 6.25, exactly the value we computed earlier. Now, when you have these, of course, you can compute the variance through this relationship, and naturally, it gives the same result.